The next concept is talking about even or odd functions. This is talking about symmetry. It's talking about, if you look at the graph, are there any reflective type properties? So a function is even when, if you can cut it down the y-axis, pretend this was just a piece of paper, picture, and I cut it right there, or I folded it along that, put the two pieces on top of each other, would I get the same thing on each side? It's basically cutting it in half. Is there a reflection? Symmetric about the y-axis. A function is odd if it is symmetric about the origin, which means, let's say I put a pin right here in the origin, and I rotated the whole picture 180 degrees, twisted it around, would I get the same picture? Now, this is hard to visualize, so lucky you, I made a cool presentation. So top left one here, kind of watch, I'm going to show you even first. So if I were to fold that y-axis, then it would become that picture. So that's what it looks like when I'm folding it over the y-axis. Do I get the same picture? No, so it's not even, that's for sure. How about odd? Here's the odd picture. I'm rotating it. Did I get the same picture I started with? Let's double check. Yes, so you would say that this is an odd function. Okay, next one, this one over here on the top right. Here's a check for even symmetry about the y-axis. Oops, just kidding. We did the origin first. Okay, I'm rotating it 180 degrees. Do I get the same picture? No, it's pointing down when they were both pointing up before, right? So it is not odd. Now looking at that one, that's folding it along the y-axis. I'm reflecting it. Do I get the same thing? No, these little bumps right here are not in the same spot. So we would say that this one is neither. Okay, this bottom one down here, let's do a rotate about the origin. Nope, not even close, right? And we're only going 180 degrees. Don't think you can flip it a whole 360. That doesn't even make sense because all we did was one circle with that. So rotation about the origin is a no. Now if you flip it along that y-axis, picture it folding in half, is it symmetrical? If I were to cut it right down here, would I match on both sides of that y? No, it fools you, but if you look closely at where that little valley is, that minimum, extrema, it's not even about that. So this one would also be neither. And that's the idea of even and odd functions. That's it. Look at the graph, kind of see if you rotated it around half a circle, would it be the same, like this one up here? Or look at it based on that y-axis. If I split it here, will the two sides match up? Okay, so going back to all the stuff we've talked about so far, we've got extrema, that's the max and mins. We've got intercepts, even, odd, or neither, domain and range, intervals of increasing and decreasing, and then end behavior. So these are the two new ones. The other ones you did in part one. So one at a time. Doesn't matter where you start. I would say intercepts are the easiest ones, right? So we've got an intercept there and an intercept there. It doesn't give us an exact amount. It's about, there's 1, 2, 3, 4, 5. I'm just going to pretend that it goes through 3. It really doesn't matter because we're just practicing. So there's going to be an intercept at -3, 0, and another one at 3, 0. Okay, y-intercept is about right there, which looks like it's at 4. So we would say 0, 4. Okay, intercepts, nice and easy. Domain, looking at the graph, it doesn't show arrows, but imagine they're here. If it wasn't going on forever, it would have put dots to let you know. So domain, remember we had that little special line that I used. Ooh, that's an awfully big line. Line, little guy. So here's my line. Come along, Oh, we're doing domains, so we got to be vertical. Okay, start about in the middle of the graph, and I'm going to go to the left, go, and then this arrow on here says that it goes on forever to negative infinity. So we would say the domain is from negative infinity. Oh, well, I said go away, and I'm losing it. Negative infinity, comma, then we take our little line here, go to the right, and again, that arrow means it's going to go on forever in that direction also. And remember, anytime it's infinity, you put a parentheses around it. Okay, now I've taken my little line, I turned it horizontally. So we start with our line, about halfway in the graph, and you start going down first. Now if I go down, the graph does not stop right there because out here on these outsides, it goes on and it continues going down forever and ever and ever. So the range, the lower number is negative infinity, comma. Okay, now we're going to move up. So starting at the middle, I'm going to go up until I run out of graph. Looks like it stops right there. There's the top, which means the y value is 20. Now, is it including or not including? Well, it's the top of the graph, and there's no holes there, so we would include that. You can also write this in the other notation, negative infinity to infinity, that is all real numbers, the whole capital R thing. This one, negative infinity up to 20, that would be y is less than or equal to 20. I'll accept either. All right, let's go to, let's do extrema. So extrema means maximums or minimums. That means any tops of the hills or any bottoms of the valleys. So each of these points is considered an extrema. This one looks like it's at negative 2 and 20. This one at 2, 20. And this guy is at 0, 4, happens to be the intercept. So extrema, there's two types. There's maximums and minimums. So if I define the maximums, I would say there's a maximum at negative 220 and at 220. And then the minimum is at 0, 4. Extrema. Done. We can go to intervals next. Intervals of increasing and decreasing are easy after you have the extrema, because all you got to do is picture this line coming down. By definition of what a maximum or minimum is, wherever that maximum or minimum occurs is the point where something changes from increasing to decreasing. So picture these three lines right here. It has split it into a bunch of intervals. So we've got this interval from here to there. Then we've got this interval from there to there. This one. And the last one goes over here. So 4 different intervals. We just have to decide, is it increasing or decreasing on that interval? So looking at the graph, picture the choo-choo. As the choo-choo's traveling along the curve, is it going uphill or downhill here? Uphill, which means increasing. Okay, going to the next interval, this green one right here. Here's my beautiful choo-choo. Looks more like a hippo, but whatever, maybe a dump truck. Okay, he's riding and he's going downhill, which means decreasing. Okay, back over here. Draw another awesome picture. That one kind of looks like a turtle. Turtle. Okay, it's going uphill. So again, that's increasing. And then we get down to this final spot. There's a little duck for you. He's going downhill, so that would be a decreasing interval. All right, now you just have to describe it. So this yellow spot right here, this starts at negative infinity and it stops at negative 2. That's where the yellow stops. Then we've got this green part right here that starts at -2 and ends over here at 0. Right? Now we've got this blue guy. Close enough. Oh, that's that guy, isn't it? That starts at 0 and ends over here at 2. And then the final guy, the purple guy, starts at 2 and ends at infinity because he goes on forever. That's so not that color, but whatever, I couldn't find it. So notice that each of these intervals, wherever one ends, the next one begins. Wherever one ends, the next one begins. Ends and begins. Also notice that it usually alternates between increasing to decreasing, increasing to decreasing. Not always, but most of the time it's going to do that. Okay, let's write these down. Get back to our little bitty one. So increasing, the first interval for increasing was from -infinity up to -2. So -infinity to -2 and from 0 to 2. Decreasing was the green one, -2 to 0 and 2 to infinity. Okay, one last thing, let's talk about end behavior. This was the new stuff, but I told you that there's going to be two statements. There's going to be one statement that says this: as x goes to -infinity, that's talking on the left side, and then there's another statement that says as x goes to +infinity, and that's looking at the right side. So looking at this whole graph right here, and it's getting kind of messy, but that's okay because all we got to do is look at this far left side. So I'm going this way, right? I'm going to -infinity, and I'm looking for the graph and saying, well, which direction is the graph going? It's going down. So your second part of this statement would be that f of x is going to down, which is -infinity. Okay, right side, I'm looking over here as I'm going in this direction. Which way are the y's going? Which way is the graph pointing? Well, it's also pointing down. So you would say f of x goes to down, which is -infinity. Okay, so there's one whole example from start to finish, all the characteristics that you'd need to be able to identify. It's kind of a messy graph. I really like my choo-choos and hippos and stuff, though. I mean, they're not bad.